Okay. Should be good. Good. Today, I'm going to be taking a look at whatever is going on with Rook Ceph here. Yesterday I got a bunch of warnings, but I was out of the house, so I couldn't really debug it. And yeah, gotta figure out what happened here. Just tons of alerts. Basically, it looks like fluent-bit was doing something crazy, and then it looks like it caused Rook Ceph to have some issue, and I don't exactly know what the issue was because we got a health warning. I don't know why. So that's what we're gonna try to find out. Not ideal. Let's do this. Actually, let's pull this into a separate thing. I just want to separate out the debugging terminals, because once I've done debugging this. So let's just tell Claude we were getting some were there other ones? No. Why is copy not an option here? Copy link, but I can't just copy? What are you doing, Slack? Can you investigate what was going on here? It seems like we got high CPU usage from fluent-bit, and then at some point we started getting health warnings from Rook Ceph. I presume they're related. I would think maybe some... Actually, we could just check this real fast. Instead of speculating, let's go here. Let's look at Victoria logs. Let's look at the last 2 days. Too much. Okay, so we're getting about 1,000 logs. That doesn't seem crazy to me. Now let's do now minus 48 hours and 51. Oh, 50. Yeah, the same. So nothing crazy there. Maybe something happened. You have a lot of logs. Whatever. I'm not gonna speculate. Now I can do this. Make sure my screen is being... Yeah, everything. Critical CPU. Did we start writing a bunch more logs or something? Why did fluent-bit start getting these really high CPU Um,
Permission requested. Command to check Ceph health detail.
I need to check on my audio levels throughout today because I've moved my mic around.
Permission
I think
requested.
they're okay.
Command to check fluent-bit CPU usage across all clusters.
But the idea was I want to be
Permission
able
requested.
to just
Command to get full Ceph status.
talk from where I'm at and not have it be too loud. It's a little bit too hot. Testing. Yeah, I think it's okay here. It's not... Yeah, it seems okay. I'm pretty sure Claude should just be able to figure out what happened here. Check this.
I ran a series of kubectl commands to inspect the Victoria logs and vmoth pods, retrieve recent events, and examine logs and restart details for the VL single pods. I also checked the cluster nodes, counted and reviewed recent fluent-bit errors, looked at monitoring pod start times, and inspected the Ceph pods in the Rook Ceph namespace to understand what triggered the vlog's restarts.
But that happened... to... Two of the three monitors OST went down simultaneously. Two of the three VL single instances died. But we were getting these alerts throughout all of yesterday. And we got another Rook Ceph health warning this morning. Long after that node restart event had happened.
Permission requested. Command to check current Ceph health detail. Permission requested. Command to check OSD performance. Permission requested. Command to check fluent-bit CPU usage across multiple clusters. Permission requested. Command to check Ceph cluster log. Permission requested. Command to try Ceph log without count. Permission requested. Command to check OSD performance and tree. Permission requested. Command to check OSD details.
Yeah, this is when we did the restart. Okay.
Permission requested. Run Ceph diagnostics command.
Nothing crazy here.
Permission requested. Command to check health report details.
Is there not a way to see what happened?
Permission requested. Command to check PG scrub status.
This is interesting. This is a
Permission
public
requested.
Ceph
Command to
dashboard?
check Ceph clock sync status.
How does this work?
Permission requested. Command to check Ceph FS status.
This is just Ceph. The Ceph health metric shows 3 distinct health warnings. Monitor clock skew, clock drift between Ceph monitor, MDS slow metadata, Ceph file system metadata server having slow I/O, file system degraded. Likely consequence of the metadata issue. So we're 7 off from that. So at 220 to 9. What's going on here? It's 240. 220 to 2. Let's see.
Permission requested. Command to check cron jobs across all clusters.
I don't see any errors or anything, but also I don't know if it would. There's not like a huge spike in logs. It's kind of what I was expecting, was that there was some huge spike in logs.
I ran a series of kubectl commands to query Prometheus metrics across multiple clusters, checking fluent-bit CPU usage, resource requests, and specific pod activity, then examined cron jobs, node CPU idle, and NTP offset metrics. I found a massive 12,791% spike in a single fluent-bit pod on February 25, but fluent-bit was flat during today's Ceph warn window, and the recurring Ceph health warn was caused by moan clock skew clock drift rather than CPU contention.
We got so many issues because of the two nodes that immediately restarted, not in sequence. This was because of our Pulumi up. We changed the cloud in it, and apparently the Proxmox provider triggers those VMs to restart immediately.
I fetched the fluent-bit logs from the monitoring agent's namespace for the past 48 hours, filtered out error and warning messages, counted the remaining lines, and displayed the most recent entries along with the previous container logs. I observed that vlogs recovered at 21:54, but fluent-bit continued to spike for an additional 12 hours.
We also seem to have gotten, for quite a long time, maybe coinciding with the node reboot event. Why would our log spike after that and stay high so long? Please. Investigate. It wasn't just the initial outage, there are two phases. DNS stopped resolving VM auth entirely on this node. Fluent-bit was now failing even faster. Then the pod got terminated. The initial outage buffered 1,000 chunks across multiple retry queues. Exponential backoff meant that those chunks didn't retry simultaneously, they staggered over many hours. Vlogs came back, but draining 1,000 chunks through HTTP takes time and CPU. Then DNS broke, causing a final spike. This tells the whole story. The actual log ingestion rate data shows normal baseline is 10,000 rows per 5 minutes. February 24th, we had 700,000 rows per 5 minutes, 70x spike, when the nodes came back online and all the fluent-bit instances flushed their backlog simultaneously. The ingestion itself was a single spike lasting an hour, but the alert stayed firing for 24 hours because of how the expression works. Yeah.
I ran several kubectl commands to query the vlog's ingestion rate and retrieve the alert expression values over a 72-hour window. I explained that a single massive spike of about 713,750 rows per 5 minutes caused the high log ingestion rate alert to fire for 24 hours because the alert compares a 24-hour rolling average to the previous 24-hour period,
Why were there so
which
many
inflated
logs?
the ratio to over 5 times the baseline.
So what's the deal with the Rook Ceph timing issue causing That was the cause of the warnings. Do. 157. 99% consistency. Not easy. Machine. The calculating walrus is affected. Sudden jumps to the signature of VM, briefly pausing. Yeah, I see. Interesting. So, what it's saying is happening here. If we were to go, let's go here. Basically, our CPU is at 16%. That's a data center. So, you know, we sit at not super high CPU utilization. We do sit higher on calculating walrus, but that fluent-bit thing where it was trying to drain those, I think. All nodes are at 2 to 4% during the window. Yeah, but this isn't right. The nodes themselves don't have to be at high CPU utilization. If something else is using a lot of CPU, it can steal the CPU, which can basically make it so that the clock doesn't work. Sudden jumps to the signature of VM briefly being paused by the hypervisor, which is what it's saying. So the hypervisor is overscheduled, which is why I wanted to pick up the new CPUs. I just have too much scheduled across these, which can cause stuff like this to happen. But I still haven't found a good deal on CPUs. I'm so stupid for not picking up the 7662 when I had the offer out on them. Just so dumb. I had an offer out and the person counter offered 335 for the 7662s. This is the Epic 2nd Gen 128 threads. And I didn't do it, and then the person sold out of them. They had them listed for like 380 or something, 370. So I should have bought them at 370. Should have bought them at 335. But I was holding out for like 300, and I thought there was a bigger difference between Gen 2 and Gen 3 than there really was. Like, it would matter a little bit, but I should have just taken the Gen 2s. I thought the Gen 3s had more stock. 7B13. I thought the Gen 3s had more stock, but apparently all the Chinese sellers are running out of stock of these. The Lenovo locks are cheap because no one wants them. But yeah, I think all these are basically just sold. Like, everyone's gotten rid of them that wanted to get rid of them. So the price has... I thought I could get these for like 550 or something, and I couldn't. And the prices have actually gone up a little bit. And now I'm just hoping someone shows up with 7662 or 7B12 or something like that for reasonable prices. Haven't seen them yet. Anyway. Yeah, that's why you get stuff like this. Is you're scheduling tons of CPUs across not that many physical CPUs. I think we have like 196 CPUs worth of VMs. We only have 32 physical CPUs. So, but it's interesting this is happening at a specific time. I want to check if there's a cron job or something happening at that time. It's using a bunch of CPU. Sudden jumps to the signature of VM briefly paused by the hypervisor. So what could be happening too is if it is a cron job, we don't have CPU limits because CPU limits kind of suck in Kubernetes. They do the same thing where they freeze the pod, but it's just the issue with the CPU limits is that they're time sliced, and so a pod can like use a lot of CPU for a short period of time, and then like not use CPU at all, and the scheduler will kill that like short burst of usage because it's using too much CPU for too long time. But that's how most programs work. Most programs don't use like partial CPU cycles. They like request the CPU and use it the entire time, and then they're done. So anyways, I don't have limits set. I wonder if a cron job or something is bypassing the CPU alerts and using more CPU than it's supposed to be using. I wonder if there's some cron job or something happening. Actually, let me just check. So, Egypt man to fish. Go / metrics. Dashboards. What do I want to look for here? Let's look at calculating walrus. And it's saying it happened at 2. When did this happen? So this is when I broke stuff. This is the... What is this? 250? So now something I'm missing here is what pods are scheduled across all clusters on this node. Copy time rate. Dashboards, Kubernetes. Paste. Apply. Don't see anything here that's super suspicious. Oh, this is app dev. I thought. Here, overview. That's what I want. Yep. Huh. What happened here? Yep. Build prod. So, this is probably when the 4JO backup happens. It's so much. Yeah, so something's doing a ton of reading and build prod. Huh. I think something doing a ton of reading and build prod. From 205. My best guess is that this is related to the Forgeo backup job, but the read IO seems really high. Around 500 per second for 5 minutes or so. Also, we see a spike in CPU usage by cluster for management prod, build prod, core, what? Oh, I see. The max is wrong here. What's up with this? Oh, it's stacked. I see. It's stacked, but yeah, build prod's just pushing the other ones up. Okay. That was confusing. Actually, we also see some container restarts during that. Go down a bit.
Permission requested. Command to check disk reads on calculating walrus across all clusters today 9/11 UTC.
So it's not the 4.0 backup. Something else?
Permission requested. Command to check total disk I/O on all calculating Walrus VMs, today 9/11 UTC. Permission requested. Command to check Proxmox metrics. Permission requested. Command to find available Proxmox Ceph OSD metrics. Permission requested. Command to check Proxmox Ceph backup completion times. Permission requested. Command to check CPU steal time on Ceph metadata VM.
Nope. This one. Yeah, it's something with build prod.
I queried total disk I/O on all calculating Walrus VMs across every production Kubernetes cluster and found 0 I/O during the 09, 00 to 11, 00 UTC drift window, then compared it with the February 25 data that showed a build prod fluent-bit I/O storm. I also inspected Proxmox host reads and writes, Ceph OSD latency, backup timestamps, PG scrub activity, and CPU steal time, confirming that scheduled backups finished well before the drift and that no scrub or hypervisor contention was occurring. I concluded that neither VM level nor Proxmox level I/O explains today's clock drift.
Why does... It's all IO weights?
Permission requested. Command to get correct UTC timestamps. executed several kubectl commands to query the CPU mode breakdown from the monitoring service for the build prod environment on today's 09, 0011, 00 UTC window, and also for February 25. And I ran a Python one-liner to calculate the correct UTC timestamps. I observed that the CPU metrics were completely flat today with 0% I weight and 0.07% steel. So I suggested checking the data from yesterday.
So I'm still not totally clear, having with fluent-bit. Why did CPU go high on spikes in it? Alright, we gotta go back to the one. It's actually hard.
Permission requested. Command to retrieve fluent-bit config from build prod environment. I retrieved the fluent-bit config map from the monitoring agent's namespace in the build prod context and displayed its contents.
The config reveals exactly why. Here's the mechanism. The critical settings. Retry limit false. Infinite retries never drops a chunk. Storage limit size 500 megabytes per output, 3 outputs. Up to 1.5 gigs of file system back buffer. Storage path. Chunk split to disk. Storage.backlog.mem limit 50 megabytes, only 50 megabytes in memory, rest on disk. Flush 1 tries to send every second. Lua filters on every log line. $256 megabyte memory limit. Outage creates a massive backlog. All 3 VL single outputs fail simultaneously. Chunks pile up 3 times as fast. 50 megabyte buffers will fill instantly. Inputs pause. Failed chunk spill to the storage on disk. Each chunk gets exponential backoff plus jitter. Victoria logs recovers, but backlog is on disk with staggered timers. Victoria logs is back, but chunks don't retry until their scheduled time. Each burst triggers as a cascade. Back off timer fires. Read chunk from file system. Decompress, run through Lua filters. Yeah, I'm trying to think like what makes me tired when I'm doing this. And I was thinking maybe it's the mic in front of my face, which is why I moved it. But now I'm thinking maybe it's because the screen isn't bright enough relative to the light I have in my face. And so I'm having to focus more to read. Try that. HTTP sends to VM auth. If success, buffer space frees up. Let's see. So it seems like this issue is not going to keep happening, so we should be fine. Which is good. But yeah, I'd just like to fully understand this behavior.
Permission requested. Command to examine full timeline of previous container errors.
Binary search. Accepts nums, number, array of numbers, and the number you're searching for. It returns a number. Low, high, nums.length, -1, while low, less than high, mid, low, is this a bit shift? Signal to right shift operator. Operator shifts the bits of the first operand to the right by the number of places specified in the second operand. That gives you the mid. Ten. Huh. I guess that does, huh? Pretty cool. It also just divide by 2, but I guess this gives you a whole number. It's always going to round up. Yeah, it's always going to round up. No. No, it'll always round down. We had an extra 1 here. It'd be 11. Shift, round down. Okay. Nums, mid. I wish they had a kind of like a navigation thing. Maybe something like Vim commands. Navigating around a file. That's one thing I find hard with this keyboard still. Just navigating around files quickly. Let's see what this said. The retries were succeeding, not failing. The log shows continuous errors. Per chunk processing, each chunk read from disk. During the morning, scrub windows, disk IO contention, load chunk reads. Ended violently. At 3:13, DNS started failing, likely related to the same item. What is scrubbing? So, and is the issue contention from Proxmox Ceph or from Rook Ceph? Got to do. Always something. I forget. Ceph scrubbing is a background data integrity process analogous to file system check for file systems. Ceph periodically reads every object on each OSD and verifies checksums to detect bit-rot, corrupted data, or inconsistencies. Scrub checks object metadata and sizes. Deep scrub reads full object data. Scrubs are scheduled daily by default and are IO intensive since they read data from the underlying disk. The contention was from Proxmox Ceph, not Rook Ceph. Proxmox and Rook Ceph are separate Ceph clusters, but they share the same physical SSDs. When Proxmox Ceph runs scrub, it hammers the physical disks. The root Ceph VM 6 runs IO stalls. But this was only an issue because of fluent-bit trying to read disk. And why did build fraud CPU spike during that time? What was happening? That was weird. I have no idea what I typed. I thought I typed the right thing. It's Thursday. Thursday. Or if I cannot type. Come on. Type myself up. Jesus Christ. There's just something about this kind of typing where my fingers are all over the place. I'm losing my position, and then when I lose my position, I don't know anymore where the right keys are. It's a pain, but it's hard. The CPU spike was most likely IO wait. CPU is sitting idle. But we should figure out what was so much.
Permission requested. Command to list available cluster label values. Permission requested. Command to check container CPU metric label structure. Permission requested. Command to check metrics on VM single 0. Permission requested. Command to check container CPU data on VM single 0. Permission requested. Command to check job labels on container CPU metric. Permission requested. Command to check instance labels on container CPU. Permission requested. Command to query top CPU consumers in build prod via VM single 1. Permission requested. Command to query top CPU consumers in build prod via VM single 2. Permission requested. Command to check build prod data existence. Permission requested. Command to check build prod data existence at Feb 2509 00 UTC.
Was the monitoring agent's namespace? It's probably fluent-bit. Didn't keep the timer in. Backlog from the messed up server. All right. fluent-bit reading its own backlog chunks.
Permission requested. Command to check container restarts in build prod feb 2509 00-1030 UTC. Permission requested. Command to check cube state metrics job labels. Permission requested. Command to check cube state metrics restart metric labels. Permission requested. Command to check container restarts in build cluster between 0900-11 00 UTC on Feb 25. Permission requested. Command to check build cluster restarts on VM single 1. Permission requested. Command to check build cluster restarts on VM single 2. Permission requested. Command to check build cluster restarts in last 12 hours. Permission requested. Command to check build prod events for restarts. Permission requested. Command to list build prod pods with restart counts greater than 0. I ran a series of kubectl commands to inspect the cube state metrics restart data for the build prod cluster around February 25, checking label structures, data retention, and querying multiple VM single instances. The queries showed that no restart series existed for the requested time window, and the current pod list revealed no build prod pods with a restart count greater than 0.
Okay.
Permission requested. Command to check fluent-bit logs for memory warnings. Permission requested. Command to check fluent-bit logs and app Permission requested. Command to count pods on alerting nodes. Permission requested. Command to check fluent-bit storage usage on alerting pods. Permission requested. Command to check fluent-bit storage directory. Permission requested. Permission requested. Command to check fluent-bit memory usage across all clusters. Permission requested. Compare log file count on high versus low memory fluent-bit nodes. Permission requested. Command to access fluent-bit monitoring API. Permission requested. Command to query fluent-bit storage API via pod IP. Permission requested. Command to query fluent-bit storage API via pod IP.
I need to add some skills, like some infra debugging skill, web debugging skill that has information specific to my infrastructure. So it knows where it can look up logs, metrics, etc. Like what the commands are.
Permission requested. Command to query fluent-bit storage API. Permission requested. Command to port forward to fluent-bit and query storage API. Permission requested. Command to query storage API on low memory fluent-bit pod for comparison. I retrieved the pod IP of the fluent-bit pod and tried to query its storage API using a curl image, then set up a port forward to the same pod and queried the API that way. I also performed the same storage API query on a low-memory fluent-bit pod for comparison.
Resetting the fluent-bit name and sets would be the right move. Rebooting the node is overkill.
Permission requested. Command to check rollout status across all 4 clusters. Permission requested. Command to check fluent-bit memory usage after restart. I restarted the fluent-bit daemon set in the app prod, build prod, internal prod, and platform prod clusters, then verified that each rollout completed successfully and inspected the memory usage of the fluent-bit pods across all 4 clusters.
Okay. So we look over all these changes. And this sets up the recovery phrase. So if you have the recovery phrase, you can get access to your account again. And change your password. But then I was wondering if we should do the pin setup. So it should have just updated this. I kind of wish I had checked the updates to all of these in as I did them, but it was kind of complicated because I didn't think to do it every single time, and then I had a bunch of updates that were really relevant to previous commits, and so then I kind of didn't do it all. Let's see. Take a look. Look at that. And our did get changed. Would you think about them? Should we change anything? Can you look at the plan again and see? Token issuance is purpose aware. Registered tokens are issued only when no account exists. Recovery tokens are only.
I read the migration plan markdown file and searched it for any mentions of Phase 4, and I confirmed that the sections read cleanly and no forward references remain.
It's currently intentional and tested. Recovery login decodes only, does not check consume state. Hardened nullability assumptions. GraphQL marks recovery wrapped salt non-null, but resolver reads DB directly from wrapped key. If legacy edge rows could have salt nil, so what do you think we'll address about the changes? And what do you think about these suggestions? Use your judgment.
I inspected the Elixir resolvers and verification modules and the TypeScript authentication context, confirming that the recovery flow consumes the token before rotating credentials and that the salt is always generated as 32 random bytes. I explained that we should refactor recovery to use an atomic ecto, multi for token consumption and credential rotation, and add a brief comment clarifying the decode-only behavior, while noting that tightening the nullability of the recovery key salt isn't necessary and the documentation is already consistent. I asked if you'd like me to go ahead and implement the atomic recovery change and the documentation comment.
Oh my god. Why doesn't Control C work? Oh, it's good. Fixed. Now the atomic pack. Stop. cleanest approach, add or replace wrap key with an optional repo param. I should just make the existing replace, yeah. Oh, my fingers. General move. Not very. USB seems. I think to own call be at C.
Permission requested. Run recovery and verification tests in the HappyGroups server directory.
Take a look at the
Permission requested. Command to run full server test suite.
page to get changes now. Does everything good?
I ran the test suite, confirming that all 50 recovery tests and the full server suite of 286 tests passed without failures. I replaced the duplicated resetAuthKey function with a new resetAuthKey atomic function that includes token consumption in the same ecto multi, restructured the complete recovery logic into a pre-transaction validation phase and an atomic transaction phase, extracted a private doReplace wrap key function to accept a repository parameter for use within the transaction, and added a concise comment to the doRecovery login function, explaining why recovery login performs decode-only operations.
If you want extra safety, add one regression test that proves token is not consumed when the recovery transaction fails mid-flight. What do you think about this? Fuck.
Permission requested. Edit recovery test file.
I can't edit this up.
Permission requested. Command to run recovery tests.
Clear. Up.
Permission requested. Command to run recovery tests with same seed.
$60.
Permission requested. Command to run full server test suite. I added added a regression test in the complete recovery describe block to delete the user row between the decode and multi-phases, edited the account's Elixir module to include a stale error field on the update change set, and ran the recovery tests and the full test suite, confirming that all 20 tests now pass. I explained that the ecto, multi, update step was raising a stale entry error, and chose to handle it by converting it into a change set error with stale error field.
Dang. It's not focused. Let's see. I think we should basically be good to commit this, and then we can move on to the last little bit of stuff. I think there's only 3 things left to do for the login, recovery, and wipe if you forget your password and recovery phrase. Doo-doo-doo. Didn't say what's done somewhere. What was done in phase 1? What was done in phase 2? It's wrong. Blah blah blah. Stage changes are coherent. Purpose null can likely crash. Check verification code resolver. Purpose to string only handles register recovery. Since GraphQL arg is nullable with default, explicit null may become nil and cause a function clause error. Add a nil clause or make arg non-null. Yep. That's what you do when you live in the woods. Practice your whistling. I need a song to whistle to though. Like a bird. Let's see. Null may be nil. Recovery error contract is slightly inconsistent with the doc. I wonder if I'll ever be able to get those CPUs. I was looking at that a little bit today. Like the Gen 3 ones are getting more expensive because I think, like you found, they're selling out of them. So I need like some data center to clear out their old inventory. But maybe that's already happened. Maybe no data centers have them anymore. Don't know. Okay. Recovery error contract is slightly inconsistent with the doc. Invalid phone and recovery login returns validation error. While the plan says recovery failures should be uniform, either normalize this to recovery failed. Minor telemetry mismatch, invalid phone, and recovery login as tag is invalid token. Yeah. I've been liking going back and forth between Codex and Claude Code. So what I do is I have Claude Code do all the work right now. I don't actually know which one's better. The thing that Codex does feel better at, which I've seen other videos where people talk about it, is that Codex seems to do a better job of keeping things consistent. So it'll like double check that there's no other references to something or whatever. Whereas Claude won't do that. yeah, I don't know. I like having Claude implement it. And then I'll create the plan with Claude. I'll put the clan into Codex, ask Codex if it would do any improvements, and then ask
Permission
Claude.
requested. Run full test suite with a 2-minute timeout.
Ask Claude if it agrees with the improvements or not. And then like look over it myself too and leave out any that I think are just kind of stupid. But usually like the first 1 or 2 passes like that are pretty good. Like it's finding things that Claude should have included in the plan that it didn't include in the plan. And just refining the plan pretty substantially. I find after a couple passes, Codex seems to have this behavior where it always...
A crash when purpose is null, an incorrect error code for an invalid phone during recovery, and a wrong telemetry tag for invalid phone numbers. I updated the schema elixir file to make the purpose argument non-null, edited the accounts elixir file to omit the correct telemetry tag, and return a recovery failed error for invalid phones, and then ran the full test suite with the mix test command.
So I find that the first pass or two, taking Claude's plan and then putting it into Codex and then asking for any suggestions or improvements, doing that like once or twice seems to be pretty high value. After the third timer, it's just like picking little things and maybe they matter, maybe they don't matter. Codex seems to have this behavior where it'll always suggest something. Like, just like the LLMs, they always agree with you. Like, they've programmed it to do that, basically, by incentivizing it to work that way. Codex seems to have a behavior where it'll always suggest something that can be improved, even if, like, it's just kind of a dumb thing. But in this case, usually the plans from Claude can be improved the first time or two. And it'll suggest things like, hey, you should run this to make sure there's no other instances, which is something Claude doesn't do by default. So I find that works pretty well. I don't know, like, it makes me wonder if you could just pipe them back and forth between each other. Makes me wonder if you could pipe them back and forth between each other, but I don't think it would really work that well. Maybe if you did it once. But sometimes the things that Codex suggests are wrong, and you want to leave those out. Purpose null crash, okay. Let's see, much better. The 2 big issues I called out are fixed. You fix the purpose nullability risk by making it non-null with a default in schema. So, safe, you aligned recovery login. Yeah, it doesn't like the unstash logs. I think this is good enough. Go ahead and look at the stage changes and commit them. Echo 2. Do not git add anything. Fix.
Permission requested. Command to commit stage changes with a detailed commit message. I ran a git diff to confirm there were no unstaged changes besides some notes files. Then I committed the 15 staged implementation files with the message, add account recovery flow for HappyGroups, and noted that all pre-commit checks passed, resulting in the commit landing as B32 B to D4.
Go ahead and make a plan to continue with the implementation. You may want May want to look at stage 3 again. You seen this, Shauna? Or else on this, it's like, what was it called? Playing God. Did a breakdown of how they made this song. Where is it at? Where is it? Playing God. He talks about how they made this song. There's a whistle. There's a guy who whistles in it. Yeah, here we go.
Permission requested. Select next phase to implement.
Video, this time for
There's no chapters.
our song Playing God. Inspiration behind that was just the sound travels and hits your. Enjoyed doing it since the melody is so good to the ears. Thank you, Sash Taneje. Anyways,
The whistle.
and I'm reaffirmed in this being one of my best melodies ever, because even he said, it took me about 5 hours to get it done, but I enjoyed doing it since the melody is so good to the ears. Thank you, Sash Taneje. Anyways, this is the whistle that I got back from him. This is without auto-tune or anything. So I tuned it.
Gotta work on my
I
whistle.
even sent him this counter. Happy list.
Which phase do you want to implement next? Vault wipe? Yeah, I do want to do that phase next, but I don't know why you labeled it as 7 originally. Let's do 7. Quick wins. And we'll save the quick wins for later. 7. $161. Ooh, peaked at 200. Gotta get to 300. It's too slow. Whistling guy on Playing God only charged $32. This is gonna take like 15 minutes. 15 minutes to come up with a plan. Do, do, do. Export function, quick select a number, low, 0, 5, hit a link. AI. I plus plus. Read the first few files. Exists.
Permission requested. Execute exit plan mode with allowed bash commands.
Take this. Plan. Copy. Clear. Now, take a look at stage 3 and at next steps. What do you think of this plan to implement the account reset? Nope, that's all right. Strong plan. Day 7 design. You kept the core invariant right. Pin failures don't consume the SMS token, and token consumption is inside the destructive transaction. Pin failures don't consume the SMS token. The burned pin cooldown and edge cases are explicit and testable. The split between passphrase recovery versus vault wipe is clear and enforced server side. Test matrix is excellent and covers the real failure modes, not just happy paths. What I tighten: verification token purpose. Your plan says reuse recovery. Your plan says reuse recovery. The phase docs transaction example use vault wipe. I'd strongly prefer a dedicated purpose for cleaner audit, I agree. Verify auth direct currently takes a user struct, not user ID. Your password authenticated pin reset should load user first. Vault-wide plus login UX has a subtle bug risk. Login currently only restores account key. If wrapped key... If wrapped key exists and at least one vault exists. Vault-wide plus login UX has a subtle bug risk. Login currently only restores account key. If wrapped keys exist and at least one vault exists. After wipe, vaults are nil by design, so normal password login may not restore account key. You should adjust login unlock logic to unwrap password even when vault blobs are nil. Keep vault wipe pin checks separate from existing verify pin flow. Because verify pin honors pin locked until. Consider session invalidation implications. Auth tokens are stateless Phoenix tokens, so wipe won't revoke old tokens. So I'm confused about this. Right now, what is the behavior when a user creates an account for the first time? Do we create the password wrapped key and vault in a single transaction? All? Or do we first create the password wrapped keys? Recovery wrapped key, and then create the vaults. For first-time account creation, it's done automatically in a single server-side transaction. The register resolver does phase A prep, then calls. Register user uses one multi-transaction that runs token consume, user insert, wrap keys insert, vaults insert, in that order, then commits once. So it's not a first create keys. So it seems like we should never have the vaults. No. For new registrations today, yes, vaults should not be nil. Register requires both session vault is non-null GraphQL Rs. Server inserts user. Why nil is still possible today. Defensive compatibility paths exist for legacy users without crypto in the web client. Data corruption / manual DB edits. Current happy path registration non-null vault. System behavior overall nil must still be handled safely. Do you think phase 7 should work more similarly to how the account creation works? Although I'm also not sure how we can handle nil vaults safely other than just creating new ones. And it seems like if one is nil, we have to override both. Which isn't particularly safe. Particularly safe. Yeah, I'd make phase 7 much closer to registration. Right now, your instinct is correct. Nil vaults create an awkward and risky repair logic. The cleanest model is registration and vault swipe both and vault wipe both. Means both end in a fully initialized crypto state. Login unlock never has to guess whether to heal partial state. Require client to send a complete fresh bundle. Commit only if all succeed. Do you think it should share any of the logic from register, or should they be parallel paths? I would not make phase 7 call register user atomic directly because the orchestration is different. They should absolutely share lower level logic. Can you suggest your original suggestions again, as well as what you would do here for the vault wipe setup? And handling the missing vault pieces. So the other issue you run into is even once you put all of this into a plan, you go through all this work, and then Claude Code's going to run out of context and not be able to implement it all correctly. So that kind of sucks. Keep vault wipe and logic separate. Okay. What do you think about these suggestions? Use your judgment. So slow. Got good suggestions. Let me evaluate each. Dedicated vault wipe token purpose. I'd keep recovery. The token proves phone ownership for account recovery. Context, building this plan. Solid set of decisions. I'd keep almost all of it with 2 important caveats. Why did I want to keep recovery? Dedicated vault wipe token purpose. The token
Permission
proves phone
requested.
ownership for account
Execute
recovery. If
exit
the user
plan.
verifies with recovery purpose, tries their passphrase, and it fails, they should be able to pivot to the vault wipe. Separate purpose would force re-verification SMS when the user changes their mind mid-flow. Bad UX for no real security gain. The server differentiates the action by which mutation consumes the token. Password authenticated pin reset. Full crypto state atomically on wipe. Separate pin logic. Two refinements. If wipe only inserts a password wrapped key, user may lose passphrase recovery until they manually regenerate. I'd strongly consider inserting a new recovery wrapped key during wipes too. Same as register. Yeah, I don't know why I didn't do that. It's weird too, like... I don't know. I think Claude does better with logic, like when you're trying to work through something. But sometimes it's just worse at basic coding stuff. Like they're both better in some ways and worse in some ways. I prefer if I'm like asking a question and trying to figure something out to use Claude. But some of these are just sort of obvious and Claude completely misses them. Shift. What do you think about these? Use your judgment. Recovery key after wipe. You're right, this is a significant gap. If wipe only inserts a password wrapped key, the user is immediately vulnerable to the exact problem that brought them here. Lost password equals lost account, no recovery passphrase. Vault wipe should mirror registration fully, generate fresh recovery passphrase, derive recovery wrapping key, wrap account key, submit both wrapped keys, show passphrase confirmation modal. Session revocation framing, agreed. An old session token can hit update session vault. An attacker could corrupt. An attacker could corrupt freshly created vaults or rotate the recovery key. That's real damage, not theoretical. While framing it as conscious security debt. I don't understand. Old tokens are not mostly useless. They can
Permission
still hit
requested.
authenticated
Exit plan
endpoints. Potentially grief/corrupt state. If you defer token version revocation, call it a conscious security debt. We're also out of context. For token version revocation. How would token version revocation work? How hard is it to do now? And what's the downside of doing it? Let's see. Revocation is straightforward to add because auth already does a DB user lookup per GraphQL request. How token version revocation would work. Add users.token version. Sign auth tokens with both user ID and version, not just ID. Today, user.signUserID. New payload like user ID and the token version. On request auth, verify Phoenix token signature expiry. Load user from DB, compare token version to user.token version. Let's see what Claude thinks. What do you think about doing this now? Are there good reasons? Number. Where are you? Do it now, the case is clear. I'd tweak that. Vault wipe only is a good minimum, but I'd strongly recommend also bumping it on complete recovery and probably also change password. We don't have any context left. We are gonna run out of context. And we basically only done one round of back and forth with Codex. Generally want to do two. Doo-doo-doo.
Permission requested. Execute exit plan mode with custom plan.
What about how do you feel about the plan now? Current math.max x current x s math.max is now very strong. It literally always says this. It always says it's very strong and we're almost ready to be implemented. There's just a few more things. And if I clear it and ask it again, it'll say exactly the same thing. few more things. Always something to improve. Improved a lot. You fixed the two biggest risks. Full post wipe, recovery UX is cleaner. Use atomic increment. On your recovery token, I think your rationale is coherent and defensible. Add explicit test for revocation on all three. In WebSocket auth, ensure token version mismatch rejects connect. I don't think I can ask another question. Okay, we got it clear. We're not going to implement this quite yet. We're going to keep revising it. Go ahead and investigate the files a bit to get a sense of what we're looking at. And also see what you think about these considerations. Use your judgment. Okay. This song just gave me nostalgia about going to a movie theater or something. I don't think people do that anymore. We have LLMs now, but what did we give up? Going to the movie theater. Lose something along the way. I think that happened before LLMs though. I have no idea what I'm typing right now. MST. Parent U E 4 months. 4 minutes. Because we had to compact, now it has to look over all the files again. Good, I now have a thorough understanding of all the relevant code. Let me evaluate your 4 considerations against the actual codebase. Atomic increment for token version, correct and important. Explicit revocation, but both would do token version or potentially stale struct. Using update all with increment is the right fix. Trade-off update all doesn't return the struct, so we need to do get to refetch in the same transaction. Explicit revocation tests on all 3 paths. WebSocket token version reject. Okay, it's updating the plan. Authenticate user, return struct staleness. Return is valid but benign in this design. Update last login. Let's see. Let's see if Codex agrees. What do you think about this? Update last login at only touches. I agree. In the current design, struct staleness is harmless because login only updates last login at. And token signing depends on token version, so user token.sign remains correct in login. A brief code comment is enough to prevent future confusion. I'd add one guardrail note in that comment if login ever starts mutating fields. Field each help field open general view program may state 155. No person help with call word nation get here. Turn such when the small person public early and oh I missed it. Do while open last fact. Bad brain. Same. Sorry. Let me add the guardrail note to the plan step 2. We've used 50% of our context. Just reading the plan and looking at the files. Clear. Take a look at stage 3, as well as at next steps. What do you think about this plan? Should we change or do anything? 150. Wonder if I can hit 200. I think some people hit 300. Strong plan. There's still some changes. Always changes. Few targeted improvements. Add active WebSocket session revocation, not just connection time checks. Right now, old sockets survive until reconnect. After token version bump, force disconnect existing sockets for that user, or enforce per message auth checks. This closes a real stolen session gap. Serialized pin attempt updates defensively. Ensure verify pin for vault wipe attempt increments. Increment/burn is atomic under concurrency. So 2 concurrent wrong attempts can't under counter skip burn timing. Make cooldown bypass state changes. Make cooldown bypass state changes transaction save with wipe. If you clear burn state before vault wipe atomic, then wipe fails, user state may be unexpectedly altered. Prefer clearing or resetting burn state inside the same wipe transaction when possible. Unify Phase 7 token doc purpose docs. Your current proposal says reuse recovery token purpose, while older plan shows vault wipe consume purpose. Good improvements. Add telemetry. Log last login at update failures explicitly. This. What do you think about these suggestions? Use your judgment. Oop. It only block on 4. Go ahead and update the doc yourself based on. So close to having all of login register vault creation set up, which then allows me to start doing profiles. After that, I have to do all of the group vault creation and stuff. But that's all done client side, and then it's just uploaded to the server. The server doesn't really have any logic around that. Good suggestions. Oh, it always does this. Claude is always trying to put stuff off. It's always like, we can do it later. I don't want to do it later. Just do it now. Easy to do now. Already handled. Good low-cost signal, agree. Oh. Just go ahead and figure out how we can do the WebSocket session revocation or on message. Connect time check is sufficient. Not sufficient. Pre-handled. Real catch. Okay. Let's see. Mostly strong responses. I agree with almost all of it. You're correct that increment attempts is atomic for increments less lock updates, but for vault wipe, burn is enforced by a separate burn pin right. So there is still a small erase window between attempt reaches thresholds and burn flag visible. It's not catastrophic, but if you want strictness, make threshold crossing and pin burned at set happen in 1 dB update for the vault wipe path. And what do you think about this? In general, we don't want to put stuff off for later unless it's a huge thing to overcome. Phoenix already has exactly what we need, and HappyGroups is already wired for it. Active WebSocket connection revocation. Already returns user ID. Phoenix auto-subscribes socket processes to their ID topic. Handles disconnect events by shutting down the socket. All we need to do is one call after each credential rotation. So it was trivial. I tried not to do it. What do you think about this? Keep hitting other keys. It's a really good direction overall. I'd adopt it with 2 guard every time. A really good direction. I think you should just make a couple changes. The WebSocket revocation approach is spot on. A trigger disconnect after commit succeeds, as you said, and ideally from the resolver service boundary rather than deepen the accounts. Keep connect time for pin atomicity. Your intent is right, but I'd be careful with one detail. Merging burn into one SQL statement is the right hardening goal. However, cross-DB expression statement semantics, SQLite versus Vitess or MySQL can differ when updating and referencing the same column in one update. all sensible. The account context should know about the endpoint broadcast. Keep connect. Focus socket test. Let me check what DB is actually. SQLite and Vitest are the DBs. Good, the cross-DB concern is real and applies to the existing code too. It'd be so nice if typing wasn't the long-term way to do things, if you could use text-to-speech. I've tried to do that, or speech-to-text, and it doesn't really work that well. Not for coding stuff, at least. And also you're like trying to copy and paste stuff, and you can't do that easily with your voice. Do do do. Really like to finish this today. I'm so tired of working on login and registration. It's pretty important. I think after Codex responds here, I'll just let it go ahead and get started. Yes, this is a solid catch, and your diagnosis is likely correct. I did a read-only scan. I only found this class of issue in one place. I don't see other occurrences of this specific ordering hazard. update this plan, and then let it get started. Let's see it. Phases 1 to 4 of HappyGroups are complete. Phase 7 implements vault wipe, the last resort recovery path for users who lost both password and recovery passphrase. Destroy all crypto state but preserve account identity. Full design is in stage 3. 2 recovery paths will exist. Passphrase recovery, SMS token only, client enforces passphrase, rotates credentials. Vault wipe, SMS token plus registration lock pin, destroys all crypto, fresh start. Right now, for the recovery flow, how does the server know the user has the valid passphrase? And then allows them to reset their... So much to remember. Which server authorizes complete recovery using a valid SMS token. The passphrase check happens on the client side. Recovery login returns the recovery wrapped key plus recovery wrapped key salt. Client tries to derive a key from the entered passphrase and unwraps the account key. The unwrap succeeds, client creates a new password wrap blob and calls complete recovery. Server then automatically consumes the recovery token and rotates credentials. So the server is trusting if the client could produce a valid rewrap, how do we know the rewrap is valid? Great question. The current design, we don't know on the server that the rewrap is semantically valid. But the server can validate today. The SMS recovery token is valid. The request fields are well formed. The DB write succeeds. So a valid rewrap is only proven later when the client tries to unlock touch decrypt and it works. So this means if someone got access to the user's phone number, then they could wipe the login vault with no real authorization. This is the kind of question I'd much prefer to ask Claude. I don't have the tokens there. Be cool if I could switch mid. Maybe I can. Although I can't use Claude in open code. Yes, with the current phase 4 behavior, if an attacker controls the victim's SMS, they can call complete recovery and rotate login credentials without proving passphrase possession. They are not decrypting existing data. Without the real account, they usually end up with unusable encrypted vault contents. SMS only authorization is enough to trigger a destructive credential rotation path today. So how do we prevent someone with SMS access from be prevented by adding a server verifiable proof of account key possession. Right now, SMS proves phone control only. To prove I really have the passphrase, the client must prove it can unwrap the real account key. Store an account key verifier on the user. Set it registration and update it on Vault Wipe. Client derives account key verifier and sends it. Server stores only this verifier. Good. Client derives client unwraps account key from recovery blob. Recomputes verifier, sends it with complete recovery. This gives you exactly what you want. SMS attacker without passphrase cannot produce correct verifier. Real passphrase holder can recover. Break down how the verifier works. Look what it looks like. Server must verify caller knows the real account key. Add a stable, non-secret account key proof derived from the account key. Store that proof server side. During complete recovery, require the client to recompute and submit it. Inputs: the account key, the account key verifier. Okay. Let's do that here. Take a look at stage 3. We implemented recovery in one of the recent commits. I think it's the last commit. Git log. Oops. But I think we missed something. You make a plan to address this.
Permission requested. Command to reset database with new migration. Permission requested. Command to reset database with new migration. Permission requested. Command to run all tests with a 2-minute timeout.
And we have to go back.
Permission requested. Run Elixir tests with output truncation.
It's a pain, so we didn't do the recovery right. Yeah, and I mean, the thing it didn't do right on the
requested.
recovery.
Exit plan mode. Permission requested. Run Elixir tests with output truncation.
The thing it didn't do right on the recovery, it's not like super dangerous, but it's definitely not what you want. What do you think? 'Wrong plan. SMS only takeover. I ship it with a few important tweaks. If account verifier stored in plain text, a DB leak plus SMS access lets an attacker replay it without knowing passphrase. What do you think about these suggestions? Use your judgment. Do you care? Well, $64. That's the highest I've done. By one extra word per minute. Now this is a pain. We gotta review all these changes. After reviewing all these changes, we gotta go back and fix the issue with the recovery flow. Basically, the way it set this up is that you have vaults that only you can access, and your password doesn't directly give you access to those vaults. Your password gives you access to a key that's stored on the server, and the key is encrypted by your password. And that key is also encrypted by the recovery passphrase. If we encrypted the vaults on the server with just your password, then you couldn't have any sort of backup recovery passphrase. So you need a level of indirection so that you can have what we call recovery wrapped keys or password wrapped keys. That way there's like a single key that unlocks your vaults, and the vaults have which groups you're in and stuff like that, and your current keys to speak in those groups and stuff like that. So hold on.
Permission
Yeah, figure out
requested.
how to-
Exit plan mode.
So anyways, you have two keys that are encrypted. You have the same key encrypted twice, once with your password and once with your recovery phrase. And so if you lose your password, you have to be able to use your recovery phrase to unlock your account and reset your password. But you can't ever send the recovery phrase to the server, because then the server would be able to know, they'd be able to read your messages and stuff. So let's get this on. So anyway, the way it set this up is that
Permission requested. Run bash command to execute Kiwi research scripts.
the way it set this up is that it gives you the recovery. You use your SMS to verify with the server that you have access to the phone number. If you have access to the phone number, it gives you your recovery wrapped key with the key that's wrapped with the recovery phrase. If you know the recovery phrase, you can unlock that key, and now the server lets you update
Permission
your
requested. Command to format HappyGroups server code.
it lets you
Permission requested. Run bash command to execute
I'm gonna
Kiwi
lose my
research
mind.
scripts.
So it lets you override the password wrapped key, but it doesn't have any way of knowing that you actually knew the recovery phrase. And so that means if someone had access to your phone number, because Twilio messed up or something, which has happened before,
Permission requested. Command to format and write code files in the Kiwi research directory.
then someone could basically just destroy your account.
Permission requested. Run bash command to execute Kiwi research scripts.
Because they could override your password wrapped key with their own. I mean, it basically lets them reset your password if they just have access to your phone number, which is not how it's supposed to be. They wouldn't have the account key, so they would basically block you out of your own account. If they had access to your phone number and they overrode the password key wrapped key, they don't have the underlying key because they don't have your passphrase, but they could just block you from ever logging in again with your regular password. If you have your recovery phrase, you should be able to get access to your account again, but it just shouldn't work this way. So now we have to have this sort of like proof setup, and then the proof setup would allow the server to know that you actually did know the recovery phrase, because it would know that you knew the account ID or account password thing. Okay, what did it say about this? This is like so complicated to explain simply because there's so many like indirection and things that just add security and reasons why you need to do it that way. Did it just agree to do these? Let's see. Correct. Theoretical. Opening it. Validate base 64. I feel like phone numbers should be mutable, but I don't know if our setup lets us deal with that at all right now.
Permission requested. Command to format HappyGroups server code.
HappyGroups. HappyGroups.
Permission
HappyGroups.
requested. Run bash command to execute Kiwi research scripts.
Nope. Nope. I guess I should make an account for this. I keep doing it. But
Permission requested. Run bash command to check for credo errors in the Kiwi research server.
okay, I gotta take her out. Say yes to this. Okay.
Permission requested. Run high priority credo checks on the Elixir project. Permission requested. Run Elixir code analysis command. Permission requested. Command to print the exit status of the last command.
Can I just log in?
Permission requested. Command to check Elixir code with credo. Permission requested. Command to display exit status.
Okay, now I'm logged in.
Permission requested. Run strict code linter on the project.
This your updated plan is very good. Big call out on your last one. Yes, phone number should be mutable long term, and that's exactly why I'd change one piece right now.
Permission requested. Command to run code analysis on the Kiwi research project.
Do we have anything that makes it more complicated than it should be to rotate phone numbers right now? Like, did we make any bad decisions? Why does it want to stash? It's kind of cool. Like, in Elixir, it's just groups of functions for the most part. And then Credo here is trying to force it to not have too much nesting. So it just makes all these like little helper functions. Do you think these changes are... Do you think Credo depth check is good?
Permission requested. Command to check and format Elixir code with strict Credo checks.
Nope.
Permission requested. Run Elixir tests with output truncation.
Bonus salt creates unnecessary coupling to mutable value. Challenge: at registration time, the client needs account UUID as salt before computing.
Permission requested. Run bash command to execute lint, typecheck, and test scripts in the Kiwi research directory.
Yes, I think these changes are genuinely better. The original code had deeply nested case if conditional pyramids. Refactored versions use multi-clause private functions to flatten the control flow. Each function now does one thing at one level of abstraction. The with chains work well. The Credo depth check is reasonable at max 3.
Permission requested. Exit plan mode.
Derived keys logging KDF lookup is phone index, so changing phone numbers changes the lookup key and the derived auth. There is no dedicated change phone flow. So no bad decisions, mostly intentional architectural choices. Phone is auth namespace. Don't tie newer verifier
I updated the
cells
Elixir
to
registration lock module by simplifying do verify pin and
But
flattening do
the-
verify pin for vault wipe. Then formatted the code, ran Credo with strict one-line output, executed the full test suite and the comprehensive lint, type check, and test validation
Alright, so it thinks
script,
it's done. Now I'm
confirming
gonna have
all
to do multiple
71
passes.
actions passed. I also explained that the refactoring
I want
reduces
to get
nested
this
control
plan
flow and
out.
improves
They're
readability by
good
using multi-clause private functions.
for the recovery fix. The strong plan, much better now. So slow. Resource salt. Dedicated client generated random salts is the cleanest approach. Same pattern as recovery salt already in the code base. Client generates random bytes, computes, verifier sends both. Server stores salt plus hash verifier. Recovery returns the salt.
Permission requested. Exit plan mode.
How does this look? Let's see. Nope. Code. No pup. Come in. This looks excellent. Server should generate verifier salt, not the client. Server owns auth metadata. Bind verifier to user context in the proof check. You already compare hash, which is good. Also include verifier. Okay. Alright, I gotta take her out. I'll be back in a minute.
Permission requested. Handle server-generated salt during user registration. Permission requested. Exit plan mode.
All right, let's see how this looks. Let's go ahead and get this started. Shift tab. Go, to take a look at stage 3, as well as our stage changes in detail. Is everything good? Did we do differently?
Permission requested. Exit plan mode.
Think about these. All good suggestions. Agree. Extra test. Clear. At stage 3, we implemented the recovery flow that's left open the possibility of SMS takeover resulting in a user resulting in being able to update password wrapped key without any verification that the passphrase is known. This is our plan to fix that. I think. Did we do anything differently or make any improvements? Fingers are cold. Hard to type. This is a strong plan. Improvements. Make base64. Ensure account key is exportable in browser crypto flow. Your verify function requires export key, raw account key. If any path creates a non-extractable key, recovery will fail. Add a test that exercises real browser key generation import settings in prod. Harden vault wipe policy to separately. The verifier closes SMS-only takeover for complete recovery, but vault wipe is intentionally destructive and still high risk if reachable with weak checks. Add explicit guardrails. I have that already. I agree with resolver first validation. I already stored the account key verifier, but the client currently only receives salt. Return account key verifier from the recovery login too, and branch client derivation by version. Make base64 format explicit and consistent. What do you think about suggestions? Is your real addition makes version rotation practical without emergency changes. Locked out base64.
Permission requested. Exit plan mode. The recovery login call is what tells us, and it's triggered on passphrase. We could restructure the call recovery login immediately after verification Permission
succeeds.
requested. Run bash command to format and test HappyGroups server. Permission requested. Exit plan mode. Permission requested. Command to run Kiwi research scripts with lint type check and test.
Faster. Hands are too cold.
I added a GraphQL test for the reset registration lock permutation
Cold.
by editing the vault wipe testx's file and inserting the new test block at the end. I then formatted the code with mix format and ran the test suite with mix test, which reported 329 tests and no failures. Finally, I executed the lint, type check, and test script, confirming that everything passed. Permission requested. Exit plan mode.
Fingers too cold. 160. Fuck. We have to compact. Right now, user enters their phone, verifies SMS code, gets a verification token. UI moves to the passphrase step, but doesn't know has registration lock pin yet. UI moves to passphrase.
Permission requested. Exit plan mode.
Wait, what? Fuck, I'm doing the wrong thing. Tell me. This goes over here. I'm just calling recovery login earlier, fine.
I created a task to add a recovery options query to the server schema with required phone number and verification token arguments. Then I added a recovery options query in the operations TypeScript file on the client, ran the full validation suite including linting, type checking, testing, and formatted the server code. And finally, I updated task dependencies and marked one task as deleted.
Do. Acting. Mm-hmm.
Permission requested. Run vault wipe and recovery tests in the HappyGroups server application. Permission
Hate this.
requested. Command to run server tests.
These ones are too long, so I have to keep getting interrupted.
Permission requested. Command to type check client code in the Kiwi app. Permission requested. Command to check prettier formatting in source and eTui files. Permission requested. Command to fix prettier formatting in GraphQL operations file.
Implementation.
Permission requested. Run full validation suite on the Kiwi research project. Permission requested. Command to verify HappyGroups tests.
Oh, it's so distracting. It's so distracting when it speaks when I'm right in the middle of a test.
I updated the vault wipe spec TypeScript end to end test to verify that the wipe data and start fresh link is visible immediately on the passphrase step. Ran the TypeScript compiler with no omit, performed prettier checks and formatting fixes, and executed the full validation suite. I noted that the recovery options transient failure silently degrades, and that adding retry logic for the preflight query would be over-engineering at this stage. And I confirmed that the shared ETS with async set to true is a repository-wide concern rather than a vault wipe-specific issue. So I left both observations unchanged.
I've staged the changes. Go ahead and look over them in detail and commit them. Do not add anything.
reviewed the diff across 23 files, confirmed everything was correct and consistent,
Did
and then I
you
committed the
create a
changes with a
task?
message adding the vault wipe recovery and session revocation feature.
Do you think we need to make a plan for this?
I explained that the problem is that all HappyGroups server test files run with a sync set to true, but share global ETS tables, and that the scope is clear enough that a detailed plan isn't required. I noted that the solution will involve a focused refactor, likely using namespacing, disabling a sync, or process scoped isolation to achieve test isolation. Permission requested. Exit plan mode.
If recovery options fails, the code has not thrown an error. Let's see. It's the rollout strategy for when you can't wipe the DB anymore.
Permission requested. Implement account key verifier for security. Permission requested. Update account key verifier implementation. Permission requested. Command to run server tests with trace. Permission requested. Command to run full lint, type check, and test suite. Permission requested. Modify account key verifier system. I edited the Elixir test files for auth and recovery to adjust the @test auth key and @send verification mutation definitions. Then I ran the full lint, type check, and test suite, which all passed. And finally, I marked task 16 as completed.
141.
Permission requested. Run server tests using bash command. I edited 3 Elixir script test files to store the previous rate limit setting, enable it for each test, and restore the original value on exit. Then I ran the server test suite and saw that 331 tests completed with 0 failures.
And yeah, I want to change the song, but I gotta finish. Let's find at look not but the state to head present plan with while getting the system boom.
I committed the changes with a message fixing shared ETS test isolation in the HappyGroups server, disabling rate limiting by default in tests, and noted that the pre-commit hooks passed with all 27 actions clean.
I don't want to go. Alright, that's committed. I think we're good. I'm gonna go ahead with it. No! Not at the end. Need the last 5 words. It's doing that. Okay. Like shit about other. First general lead must not like deal. Such change not know. Last it by few old. Only house school from Caldwell. Course on. No mistakes. No. Can't focus for that long. So hard to focus for a minute. It's so hard because you're trying to like keep track of where your fingers are the entire time and focus and read the words, and your mind's also just like wandering. He's trying to do it for so long. And then you're also trying to not make mistakes. Like if. I just have such a hard time focusing for a minute. I start thinking about other stuff. It's such a funny thing while I'm doing this. The typing, because my mind starts to wander, and it's just like so funny. Like I'm like trying to type as fast as I can and like read the words, but my mind's also just thinking about like I don't even know, so many random things because you're just like bringing these random words into your head and like trying to focus. We have to compact here. Like finish that. Let me finish 100 without making a mistake. Focus. Hold on, Web. This is so best right now. Not in the zone. What are you doing, Web? Causing chaos. Causing chaos, Miss Web. The account key verifier is basically a proof string. The client takes a 256-bit account key and runs the key distribution function with their salt, a context string, increases 32 bytes. Server never stores the raw verifier.
Permission requested. Command to reset test database with new migration.
If you store the raw verifier, anyone with DB read access can copy it and later use it directly. Yes, the reason inversion isn't feasible is the cardinality. This is not a human password space, it's derived from a random 256-bit key.
Permission requested. Command to drop, create, and migrate test database.
Why not hash before? I see. Okay, that makes sense. So you can't hash the verifier before sending it to the server, otherwise then the hash version is the secret. Could accidentally leak, but
Permission requested. Command to check skew, light DB files, and test server configuration.
Okay, we gotta go.
Permission requested. Run lint and type check in the Kiwi research directory. Permission requested. Run tests in background.
Drive a deterministic signing key pair. Server stores only the public key. Recovery login returns one-time nonce. Client can get the message that binds all critical contacts. Unsigned. No reusable verifier secret.
Permission requested. Command to run tests after regex fix in the Kiwi research directory.
It adds protocol complexity. Deterministic key derivation needs a well-specified stable. When account key changes, signing key changes too. I think I'll probably call it for today. And I'll think about this tonight. And get ready to do this tomorrow. I gotta figure out if I want to do that approach. Basically, right now, the setup is the client uses their account key. It uses their account key and creates a secret based on the account key and then sends that secret to the server. That secret is what you use to reset your account if you have access to your SMS. So if you have access to your SMS and you have the recovery passphrase, you can override the password wrapped key so you can reset the password. Yeah, if you can, you still wouldn't have access to the account key, which is what actually unlocks the vaults. So you still couldn't do anything, like your account would be in a messed up state. But the point is if someone could take over your SMS, they could immediately, so the current setup prior to what we just implemented is that if they had access to your SMS, they could immediately basically break your account. They could take over SMS. So we fix that by having this.
Run test suite in Kiwi research project.
We fix that by implementing this secret that's derived from the account key. Then you pass that to the server hashes that and then saves that in the database. So the server says you got to be able to send me the correct key. I'll hash it, check it against the database. But then this makes the server a weak point. So if someone was able to steal your SMS identity and also steal information from the server, then they could reset your account, like basically break your account. I mean, I think like if they can get into the server, they can kind of break your account anyways. So the only situation is if they could get access to this secret in transit and take over your SMS. SMS takeover is like a real thing that can happen. And like I said, they can basically break your account if they do that. You could still get back into your account with your account recovery key, but I think once your password was changed, yeah, once your password was changed, actually I wonder now. I think we have a few places require the user to enter their password, like resetting passphrase. How does that even work right now? We can't send the password to the server. So what do we do to check? Okay, everybody. We're gonna wrap this up.
Permission requested. Command to auto-format accounts X file. Permission requested. Command to verify lint and type check pass. Permission requested. Command to check final lint and type check summary. Permission requested. Command to check final lint and type check summary. Permission requested. Command to fix prettier formatting in client files.
Change password requires old auth key. Doesn't the auth key...
Permission requested. Command to check creator warnings in the Kiwi application.
That's right. I forgot there were two different keys. Man, so much freaking stuff going on.
Permission requested. Command to format resolver's file. Permission requested. Command to run full lint, type check, and test suite.
Signal just has so little like data on the server. It's all driven by the app.
I ran the full validation suite, executing linting, type checking, unit tests, and end-to-end tests.
I ran for 35 minutes. The current scheme's main weakness is the verifier is a long-lived bearer token, same account key, same salt, same verifier every time. If the request body is logged anywhere, that verifier is replayable until the account key changes. Your challenge response scheme eliminates that entirely. The DB leak story also improves meaningfully. Right now we store SHA-2056 verifier. An attacker with a DB dump plus SMS access would need to brute force a 256 key, which is infeasible. But with your scheme, the DB only has a public key, so there's literally nothing to brute force. ED 255.19, 255.19 in browsers is painful. Web crypto has no ED 255.19 support. You need to either ship a JS library or use which web crypto supports natively. The key distribution function to ED25519 seed path also needs care. You can't use crypto.subtle.import key. If you go this route, I'd suggest ECDSA. A DB table means one more thing in ecto.multi, more cleanup, potential scaling concerns. Assign challenge token avoids the table entirely. The server re-verifies the HMAC and checks expiry. Nonce replay is covered by the verification token being single use. This trades DB state for a slightly larger request payload. Concurrent tabs / challenge expiry. User opens recovery in 2 tabs. Each recovery login call generates a different challenge. Tab A's challenge might expire while the user is trying and typing in tab B. You'd need either a short but not too short expiry, or allow the client to recall recovery login for a fresh challenge without redoing SMS. The current design already supports this since recovery login is read-only, but with a challenge table. Each call creates a new row. Decide whether all challenges are invalidated or all remain valid until expiry. The signature payload binding is the real win. Binding hash, new auth key, and hash into the signature means even a man in the middle who intercepts the signature can't swap in different credentials. This is strictly better than the current scheme. What's going on? What do you think about these? I gotta wrap this up. I'm getting hungry. I'm trying to see what this is. I think it's probably worth doing this. You're right about the core win. Static verifier is a long-lived. What is this? This guy trustworthy? Maybe just one. On the replay guard also agreed the verification token being single use covers the happy path, but there's a window where the challenge signature could be replayed against the same not yet consumed verified token. The lightweight challenge ID replay cache. Oh my god. I've got to get the distributed caching working with Elixir. For the rate limiting, and then potentially for this. I just don't have that done. I don't know if I should use memcache or something instead. I'd like to stay in Elixir. It's kind of like one of the reasons to use Elixir is I don't have to go set that kind of stuff up. This guy's funny. Oh, that was only one. Does this guy work somewhere? Alright, I'm calling this. I think I'm gonna have it create a plan. Create a plan. Yeah. Alright, I'm calling it here. I might mess with this a little bit tonight, but yeah, if anyone's watching. Thanks for watching. Have a good night. Or if you're watching later, have a good morning, afternoon. See ya.